to this. Welcome to Denver. Amazing to be here and moderating this panel with amazing panelists. This is on account abstraction. So we have great experts here. I'll let you guys introduce yourselves, but you are from the Ethereum Foundation, Alex from zkSync, and Julian from Argent. And maybe we can go from Julian to Yoav, and just briefly say what you do and what your project is about, and then we'll get to the discussion. So.
Okay, thank you. So I'm Julian, one of the co-founders at Argent. And at Argent, we've been building smart contract wallets since 2018, which is, as we will discuss, a form of account abstraction. And of course, so we've been pushing for the account abstraction narrative, because for us, it's the dream, in a sense. Having a chain where our model is native is what we've been hoping for 5 years, so very happy to discuss that.
Hello, my name is Alex Kulchowski. I'm co-founder of zkSync, which is the zk rollup implementing zkAVM to scale Ethereum. And we're extremely excited about account abstraction because we believe that this is the technology that will unlock the next wave of real-world adoption with users. So we partnered early with Argent to support something like experience similar to account abstraction as zkSync Lite version 1. And for zkSync Era, the zkAVM network, we implemented account abstraction natively, largely following the standard AP 4337, which Yoav will introduce.
Yeah, so I'm Yoav Weiss from the Ethereum Foundation. Yeah. So my name is Yoav Weiss, and I'm a security researcher, and I've been working on account abstraction for quite a long time. And I'm a co-author of ERC 4337. I was also supposed to give a talk here right before this panel, but unfortunately it was impossible to find a place on time. So I was going to announce that ERC 4337 is live on mainnet. Thank you. And, all right, let's start.
All right. Okay, so and I'm Camila Russo. I'm the founder of The Defiant, a media platform focusing on DeFi and Web3. And well, I guess to start, do you want to talk more about this EIP and what its significance is?
Yeah. So no, account abstraction is an old idea. It's actually as old as Ethereum, and there were many attempts to. There were many attempts to do it at the protocol level using various EIPs. And it turned out to be difficult to do it at the protocol level, and we needed to start experimenting. So we did it in the form of an ERC, 4337, which allows us to experiment with account abstraction immediately on any EVM chain, since it doesn't require protocol changes. And this allows us to start building a decentralized ecosystem with separate mempool, and start having account abstraction wallets and experiment with it.
And maybe Alex and Julian, can you talk about what account abstraction does for the end user? Like, why is it something that we want to implement?
So I think for us, account abstraction is the only way to bring a user experience, a simple user experience to users. As we all know, the user experience of self-custody on Ethereum has been very, very complicated, because to interact on-chain, you typically need to manage a private key or a seed phrase. We know that this is very complicated. People lose their private key, get hacked, and so on. So actually, being self-custodian on Ethereum is very, very complicated. And the reason for that, it's because the logic has been hard-coded in the EVM. So the definition of an account on Ethereum is fully hard-coded, and it has been coupled to this signer or this private key. The idea of account abstraction is basically to break that coupling and enable anyone to basically program the key functionalities of an account. So with account abstraction, your account becomes a smart contract where you can put the logic that you want. So that means that you can use that logic to really build good user experiences. As an example, for example, something we did at Argent is pioneering social recovery. because we wanted to get rid of seed phrases. And so we find a way using a smart contract or account abstraction to let users completely forget about seed phrase and use the concept of social recovery. Something else you can do is do sponsored transactions. A lot of users will come to crypto for a use case, and maybe they just want to have DAI or USDC. Why should they have ease just to pay transaction fees? So using, again, the logic in your contract, you can delegate the payment to another instance, say the dApp you're interacting to. And so now users can actually use a simple wallet without having to think about transaction keys. But there's also a lot more use cases. We've pioneered ideas such as session keys, to enable online on-chain games to basically not require users to sign every transactions. And I think all these are just the beginning. We are just scratching the surface. By making accounts programmable, it's basically a completely new design space for developers. And so I think there's a lot more use cases that will be built in the coming years.
And well, what about you, Alex? Like, how are you excited to use this new technology?
So for us, zkSync is on a mission to scale Ethereum to the extent of real world, to support real world use cases, to bring hundreds of millions, billions of people, and to scale Ethereum not just on the throughput level, but with all its values. It's really, really important to keep the values of decentralization, censorship resistance, self-custodiality. And until account abstraction, it was not possible to keep your account both self-custodial, fully, truly owned by you, and also usable, and compete with the neobanks and Web2-like experiences. So like we see the user experience as one of the key components of bringing crypto to mainstream. And this is why we decided that we're going to support account abstraction from day one, from the launch. zkSync era is now live on mainnet for developers. Builders can deploy applications there, and we will soon open the. It's actually open for the users, but in some subtle way. But what was important for us is to implement it natively. Like, unfortunately, on Ethereum, it's really hard to make protocol changes. So EAP 457 had to do it like tangentially without touching the protocol. So it introduced some limitations, some like points of centralization. We decided that we want to follow as closely as possible the EAP, but actually make it at the protocol level, so you don't have any centralized actors involved in producing. And we hope that eventually Ethereum will also embrace this approach. Maybe Yoav, you can comment on this.
Yes, so ERC 437 is definitely not the end, it's just the start, it's the first step. And what we expect to happen is that other layer 2s, much like zkSync has done, will also do things at the protocol level. And one day we'll even be able to do this for Ethereum, although this will take time. But the importance of having a standard is that wallet developers will not have to develop for each chain separately. So wallet developers will develop once. It will work the same way everywhere with feature parity, which allows them to compete on features and flexibility for users rather than getting fragmented across chains.
So is the end goal for Ethereum to be able to have account abstraction at the protocol level fully, like in the way that zkSync is implementing it?
Yes, my end goal is to eliminate EOAs, to eliminate externally owned accounts altogether. I think they are bad user experience, bad security, and we need to replace them. And this is just one more step on the way to eliminate it.
So, I mean, does that mean that Ethereum users in the future won't have to, I mean, the way that we interact with Ethereum will completely change? Like, we won't have to remember our seed phrase? Is it, I mean, it just like, it changes my concept of like how you use a blockchain like in the first place.
Yeah, that is exactly right. Because I don't think the next billion users are going to be writing 12 words on a piece of paper. And key management is hard. People don't know how to do it, and we can't expect everyone to do it right. So users should be adding devices to an account. They should have devices. They should not have keys. And you should always have a recovery option. Just like in your bank account, when you use online banking, you are never worried that if you lose your password, you will lose your bank account. Someone is out there to help you. What we need to do is to have the same user experience of a bank without having to trust a bank. And that's the purpose here.
I love that. The same user experience of a bank without having to trust a bank. And so that means that you'll have, just a regular password for Ethereum that you can recover?
So it depends. What's great about account abstraction is that you can change the implementation as you grow. So when you start as a new user, maybe you just want something simple, whether not even a password, just add a device and have a recovery option, maybe even use a centralized recovery service that can help you with that, and it's still better than what we have now. But then as your needs change, maybe you become more accustomed to the blockchain and you also have more value, then you can start having more features. You can start changing implementation of the account in place with the same account. And then the user experience can change entirely to fit your current needs.
Interesting. And what's the timeline for this? I mean, it's of course really hard to say, but what do you think?
So it's possible right now with ERC-4337. That's the idea. It's not permissioned. You can so anyone can start using it right away now that it's audited by OpenZeppelin on mainnet. And many wallets are already being built. Some of them are right here in the audience. So people are building wallets, and you'll be able to start experimenting with this user experience. And then over the next couple of years, when more and more layer 2s and at some point even layer 1 will introduce a protocol change, it will become more efficient, it will become cheaper to use. But from user experience standpoint, you can start experimenting right away.
Maybe if I can jump on that, I want to say that it's not that it's available now because of 4337. All the features that you can get from account abstraction have been live, for example, with Argent since 2018. Social recovery was in Argent in 2018. Gas abstraction, user not paying gas fees, has been live in Argent for 5 years. And today, it's been live on Starknet as well, which is supporting native account abstraction, and it's live on zkSync Era. And I'm actually happy to say that Argent Mobile is now supporting zkSync Era. So all these benefits, they're available now using 4337, but they are also available on zkSync Era, on Starknet, and they were available before on Smart Contract Wallet. But the benefit of 4337, as you have said, is to bring a standard, which we hope will help push that to a majority of users. But all these features, they've been there.
Yeah, no, I was surprised that they were going to be implemented like at the layer 1 level. Super interesting. And from your experience so far, having used all these features so far for years, what are some of the learnings? Like, are users finding it more intuitive? Like, how's the retention with?
I mean, I think Argent, we've demonstrated that this can bring the ultimate user experience. Really, when we started Argent, we used to sponsor transaction. There was no seed phrase and there was no transaction fee. So for users, it was really like Revolut or Venmo. And users, they loved it. But of course, gas fees went crazy and sponsoring transaction turned out to be not such a good idea. But I think that demonstrates that the user experience was the right one. The problem is that we were building that on a chain that wasn't really scaling, where transactions were very expensive. So that's why we started engaging with zkSync, for example, because we wanted to have a chain that would scale, have cheap transaction, and with native account abstraction, we could reproduce that same model. Another learning that we've learned, and I think that's a call for the developers in the audience, is that smart contract wallet or account abstraction on a chain that still supports EOA makes smart contract wallet a second-class citizen. Because the majority of developers, they're not thinking in terms of smart contract wallet, they're thinking in terms of EOAs. And there's a few flows that dApp developers use that are not directly compatible with smart contract wallet. For example, many dApps ask users to sign off-chain data just to prove they control the account, their identity. And for that, they typically verify that using EC Recover. But smart contracts generally cannot sign transactions. So for smart contract, you need to actually ping the account and say, is this a valid signature? So what we've learned over the past 4 or 5 years is that smart contract wallet or account abstraction really enables the user experience that we need as an ecosystem to scale to billions of users. But unfortunately, if we do that on a chain that still have VOAs, there will always be friction. There will always be dApp developers not aware of this new paradigm, and so that will kind of degrade the experience for smart contract wallet. And that's why, as you have said, account abstraction is great, but the ultimate goal is to get rid of VOAs. DApp developers shouldn't have to think about what they are programming for. There should be one easy model to make sure that smart contract accounts are compatible everywhere. And that's why, of course, we are very excited to have native account abstraction, because that makes smart contract wallet the default account on that network.
Alex, and for zkSync, is the main reason for smart contract wallets to use it is it this ability for the wallet itself to take on the gas fees for their users in a way that it doesn't immediately get out of hand, like just very cheaply be able to pay transactions for users?
So this is one use case. We discussed that there will be many use cases. We cannot foresee all of them. But there are certainly some that I am personally very excited about. So it doesn't mean that it's only the reason why zkSync is building account abstraction. We want to enable developers to invent new stuff and to come up with greater ideas. But yes, paying fees in any token, not having to bother with what is gas, do I need to swap. I have a friend of mine received 1,000 USD, he was paid by, he did some job with someone online. He was paid 1,000 USDC, and he wanted to send it to his bank account. And he was like, how do I do this? I said, well, you need to change it, just send it to an exchange. And he said, I tried to send it to an exchange, but I didn't have, told me I don't have enough funds, but I have $1,000 there, why don't I have enough funds? I said, well, you need some Ether to pay for the transaction. He said, I know, he told me this, so I tried to swap it for this USDC for ETH, but it told me that I need ETH to swap. It's this catch-22 loop that is how can you onboard people with this? It's just not bad. But this is just one aspect. What I'm really excited about, what catches my attention is security, or this interplay between UX and security. Every time I sign a transaction on chain, whatever small transaction is, I look really carefully in the hex data of what am I signing there, because you might be you see in your wallet you're just sending this you're paying $10 for in gas fees for the execution, but you don't really know what's happening under the hood. Maybe it just takes all of your money, all of your other tokens, and sending somewhere else, or your NFTs, or just changing the ownership of your account, etc. And with EOAs, it's impossible to prevent. Your key can do anything, so you have to really guard yourself against doing anything that could be malicious. With account abstraction, you can separate that. You can first of all, protocols have to be aware of this. If you build things like ERC20, it's going to be problematic because the UX. I mean, we can solve it with account abstraction by batching transactions together, but you fundamentally have to do multiple transactions, one to approve a token, one to actually send them, right? So when the protocols are aware, you can build things in a way that have, for example, daily spend limits, how Argent implemented it. Or you can have something that says if the total value that is going to be spent is more than a certain amount, then it requires a 2FA. It's not enough to send it with your wallet, but you also have to confirm it on some other device, or maybe from online. Or generally, you can take a cost signer, implement it a lot easier, not through some MPC logic which is hard to swap keys, etc. But someone can be monitoring in real time what you're doing with your transactions, detect fraud in real time, and stop transaction from happening, and actually prevent the damage. So as Vitalik recently wrote in his post about user experience, good user experience is not about the average use case, it's about the worst use case. It should be reliable and should not be afraid to make a payment. You're not afraid to make a payment today with a credit card on the internet. But it was the case in the early days of credit cards on the internet. Right? So we need to transition to that, but we need to move faster than the evolution of the internet. We can learn from all the mistakes of the past.
I think like these use cases to improve security are amazing, but does it mean that each specific wallet building with account abstraction would have to implement these different features? Like, will it depend on what wallet I'm using, whether I have these security measures?
I think it should be standards that, like, we just need to define better standards, assuming that the wallets are now smart and they can contain logic. So now you can say, okay, like, let us actually, like, for this transaction, let's define, like, what is the total impact of this transaction is going to be. Like, you can define it as a, you know, like we call it invariance in math or in security programming. You can define an invariance saying, like, after the execution of these transactions, all of my accounts, all of my balances have to remain the same, except maybe for this balance, right? And then you can execute any code, and this is part of your smart contract wallet, for the account abstract wallet. At the end of the execution, the wallet will look at the balances, and if they changed, not in the way that you expected, it will just cancel like the transaction, right? So like the wallets don't have to think about it, and you don't have to trust wallets or any centralized servers to monitor it for you. It will be code immutably deployed on your the account you own and you fully control. This is how I imagine that. Maybe guys, you can comment more.
Yeah, I mean, this is what you can do today, right? You mentioned 2FA, for example. The idea of 2FA is very simple. Because you can program your account, you can add a second key to that account. And you can say that that key needs to co-sign every transaction. And now you can give that key to a service that you want. And every time you make a transaction, the service will inspect the data. Because of course, we human, it's complicated to understand what a transaction will do. It's hexadecimal, it's very, very hard. But if you can give that to a machine, that machine can say, oh, okay, actually the account, you've been interacting, you've been sending money to that person many, many times. So this is a known transaction, I'll automatically co-sign. Now suddenly you're trying to send, $10,000 to someone you've never interacted with. The service will say, hey, you know what, confirm your identity with a second factor. So that makes it very, very, very simple. So yeah, all these things can dramatically improve. Something I think I haven't mentioned enough is the power of multi-calls as well, so batching transaction. One of the key problems of Ethereum is that every time you want to do something, you typically need to do many transactions. For example, if you want to swap token on a DEX, as you mentioned, you need to approve the token, that's one transaction, wait for it to be mined, and then you can finally make your swap, it's a second or a third transaction. And typically, because that's a terrible UX, people have taken the pattern to approving unlimited amounts so that they don't need to do these steps multiple times. And I think people don't realize, but a lot of people are basically saying to a random contract, you know what, you can take all my tokens when you want, just for the convenience of security. And that has been the standard so far, there was always a trade-off between convenience and security. And if you can start to program your account, you no longer need to make a trade-off. You can have the best of both worlds. So you can really build the best of Web2-like experiences without compromising on security security. And so, for example, multi-code is very important for that because you can batch all your action in one transaction. Something that I find interesting as an example, there are people doing implementing the concept of a shopping cart. So you go typically to an NFT marketplace. Instead of selecting one NFT, approving the token, buying that NFT, you can actually really go shopping, create a shopping cart of the 15 NFTs you want to buy, and then in one transaction, you can buy all these NFTs because your wallet will orchestrate the sequence of execution to make all these interactions happen. So suddenly, every interaction can become one click. It doesn't matter if you want to do a crazy complex DeFi protocol, everything can be one click. And again, this is bringing Web2-like experiences to Web3, which for us is the main driver and the main motivation. Bringing easy experience without compromising on security.
So batching is indeed the low-hanging fruit of improving the execution part of the transaction, of improving what the wallet can do for a dApp. But it can go well beyond that. We just need more standards for it, so that it will not be done per wallet. For example, you could have a lot of automation. You can have things like recurring payments, where since with account abstraction we separated the authentication from the execution, or the authorization from the execution, which means that you can pre-authorize certain things, and then you don't need to be the person who actually triggers them. So recurring payments is one simple example where you authorize a merchant to charge you a monthly fee, and then you don't need to sign a transaction every month. Your wallet is going to allow them to withdraw it. But it can also do much more complex things. For example, you could set certain conditions, conditions in your account, such as I want to perform a trade, I want to trade a certain token, but only if the price reaches a certain level. But I don't want to be waiting at my computer until the price is reached and then send a transaction. With an EOA, I would have to, because I need to be the one signing the transaction. But with account abstraction, I can send a transaction that creates the condition, and then a DApp, or even it can even be decentralized. The wallet can even incentivize, the account can incentivize anyone, like MEV searchers, to see that the condition is met, and then get compensated for triggering the trade in my account. But they cannot do anything bad with it, because all they can do is trigger something that I pre-authorized. So all of these use cases can make, it can really improve dApps in DeFi and in other spaces. And none of it is possible without having account abstraction.
This is super interesting and exciting for the future use cases on Ethereum. But I'm wondering, we have a couple of minutes left, how these new technologies will interoperate with old dApps, because like right now, like when using smart contract wallets, it's great, but it's also kind of it's hard to interact with everything that's out there on Ethereum, and that's what makes it just like there's a friction there. So will that be the case going forward with account abstraction, that it's just hard to use dApps that were built before?
So I think dApps will adjust to benefit from these features, but in order to do that, we need to break a cycle here. We need to make sure that people start using these wallets more, so that dApp developers treat them as first-class citizens. And one way to do that is to start giving the best possible user experience right now, so that people really want to use these wallets. And then this will, then users will ask dApps to add support for it, and dApps will start also automating things and doing things that were not possible before. So it's not going to happen in a day, but we need to start building in order to make it happen.
And maybe if I can add to that, I think today is a great time to actually make that happen, because we see the emergence of layer 2s. You are right that on L1, on Ethereum, there are dApps that are there, and some of them are not upgradable. And so if they are using the one or two things that prevent using smart contract wallet, it may be hard to make them change. But we are seeing the rise of all the layer 2s, which are kind of starting on a blank page. So I think it's an amazing opportunity to say right now, let's make sure we build apps that are supporting smart contract wallet. And it's actually very simple. There's only two things that are breaking smart contract wallet. One is the use of EC recover. And so as a dApp developer, if you are using EC recover in your code, just check that you are also using EIP 1271. And for example, on zkSync era, the compiler will either tell you with a flag, you are using EC recover, this is like an anti-pattern, make sure you support smart account abstraction. And the second thing is the use of transaction.origin, which is a bad pattern from the start. So as a developer, there's basically two opcodes that you need to prevent in your smart contract and in your dApps, and that's it. So it's not like it's complicated. So if you're building on a layer 2, please just check these two things. Make sure you just don't use EC recover or transaction.origin. And if you don't do that, you will be AA compatible. So I think it's very simple. And now that we are moving to layer 2s, is the right time to make that happen.
Okay. This went by so quickly, but thanks to the panelists, really interesting panel. And yeah, it looks like we'll have a much more usable Ethereum and blockchain future with account abstraction. So, and everyone start building on this technology.
Thank you.